Hey everybody, it's Mrs. C. And listen, I've been asked by several people to do a screencast on factoring and quadratics, to be precise, as you see on the screen. And I thought that was an excellent opportunity to show you a little bit more detail of what we've been doing in class. So what we're going to do here, or what I'm going to do, and you're going to watch, or you're going to do, then you're going to fast forward, then you're going to watch, or pause and do, and then watch. However you roll out there, I'm going to do some quadratics, and I want you to notice they have a leading coefficient, or meaning your quadratic term, right up here, is greater than 1. You look over at number 8, the coefficient of your quadratic is 9, and number 7, quadratic coefficient is 7. So we need a different approach to what I call the sum product method, and so here we go. The approach that I like, and there's a lot of them out there, shout out to all you teachers who have come up with innovative ways to make a pretty guessy, checky method into some kind of structure, but this is how I like to do it. And I can't remember how I learned it. It's called splitting the term. So what we want to do is we want to take the 7 and multiply it to the 28. However, I want it said, I don't have a calculator, and I honestly don't know what 7 times 28 is off the top of my head. So I'm just going to break down 7 times 28 into 7 times 28. And whatever that is, if you'd like to go and find out, just go ahead and put that number right up at the top. And if it makes you better to see it, go ahead and then break it down. But I want to show you, you don't need to do that. So 7 is prime, 28, 7, and 4. And if we look at this, we have 7 times 7 times 4. Now, I specifically remember this problem in one of my classes. I don't know how many. So those of you that are saying, this looks a little familiar, you know what? I think you're right. And good paying attention. Way to look out for me. So what do we see? We see 7, 7, and 4, and then I just see that 7 times 7 is 49, 49 and 4. You got it. 49 and 4 is going to give me 53. So again, what we're trying to do is we're trying to take the two numbers. They give me a product of that, whatever it was, 7 times 28. And we want them to add or subtract to be this center term. And so what we want to do, because this is called splitting the terms, you're going to just split 53a into 49a, and what's going to be positive 4a. Now I'm going to erase this nonsense on the side because I don't have enough room for it, because I want to bring down that 28, positive 28, and squeeze in the front the 7a squared, put a plus sign in between those, and there we've split the term. So really what I have is that value and that value are equivalents. So 7a plus 7a squared plus 53a plus 28 is equal to 7a squared plus 49a plus 4a, which equals 53a plus 28. So we split the term. We made it more complicated looking, I think. This isn't making me feel better. It's making me get a little nervous. Now, split your problem right down the center. So you got 2 on one side and 2 on the other. And here comes the fun. I want you to find the GCF of both sides and break it down with what I call reverse distribution. So let's think about it. I'm going to come over to this right side first. 4a and 28, they share a 4. And then if we factor it out, 4 times a plus 7. You should be able to factor these problems like that relatively easily with relative ease. If you're having problems with this that I just did, don't know where I got that from, I need you to go back and review some of the screencasts on the reverse distribution method, the factoring out of GCF. So coming over to this left side, I'm going to factor out a 7 and an a, and then I'm going to say a plus 7. Okay. Now, what I want you to notice, really important, this is the best part, I got a match here and here. these parentheses actually are the same. And that's really crucial for this method. You need that. So where I have parentheses that are the same, I'm going to copy that, a plus 7. It's just telling me that a plus 7 is a factor of the original polynomial. Then I'm going to take this term and this term. What sign is the 4? Very good, it's a positive 4. I'm going to put those two together in their own little parenthesis set, 7a and a positive 4. And guys, that is the factored form. A nice check step would work, whatever you would like. You could use the box method or FOIL method to verify that it's the same value. I mean, what the heck, let's do it, right? A times 7a, this is FOIL, first and first is 7a squared. Okay, what's O? Outside, so a times 4 is 4a. Look familiar? This is what we split it into. Remember, we split that product into a 4 and a 49, so watch how cool is this. 7 times 7, that's 49. There's the 49 that we did, A. And then, of course, we got to do the backs, and that's the 7 times 4. They're not the backs, they're the lasts for FOIL. That's the plus 28. So this looks really familiar. This was that middle step. More arrows. This is getting pretty arrow crazy. That's that one. If you combine these two and undo the split, you're going to get the 53, which brings you back up to that one. Oh my gosh, there's too many arrows. I got it. Don't worry, guys. I'm going to erase it. But I have to erase it slowly because I can't clear the screen or my image will disappear. Let's go over to number 8. While I'm erasing, take a look at number 8. Tell me, do you know what you're supposed to do? All right, let me move you over. Can you move over a little bit? Okay, that's about as good as I can get. Okay, well, if you remember the process, you take the 9 times the 21 and you multiply them together. Yet again, I don't know what 9 times 21 is. I think I could probably do it just to prove to you something. So I'm going to write 9 and 21 as the factors in my little factor tree. And then I'm going to do 9 times 21 in my head. And I'm going to get, 189. Then, of course, I'm double checking. Yeah, I'm feeling pretty good about that. So 189 is actually what you get when you multiply those two together. But then to do a factor tree, you have to break them back down again. So then you'd be thinking to yourself, 189. What are the factors? Well, 9 and 21, that would be a start. So you see how it's an unnecessary step. All right, well, this came to mind. The 3 and 7 gives me the 21, and the 3 and 3 gives me 9. They're all primes, so there's got to be some combo of these guys that is going to give me what I need. And I'm pretty much thinking there's only one way to go here, because I need a really big number. I need 66. So I think if we take these guys and multiply them all together, 7 times 3 is 21. 21 times 3 is 63. So these guys actually come back together to be a 63, and that one is a 3, and yep, 63 and 3 going to give me this 66. Awesomeness. Get out of here. I don't need you anymore. I am going to leave 63 and 3 there because I'm afraid I'm going to forget and then have to do that whole thing over again. It's early in the morning. I don't have the sharpest brain in the box. Brain in the box. There's a bumper sticker for you. Sharpest brain in the box. So we are going to split that term. And let me just, if you don't mind, I have a little more space over here. So we're going to write 9k squared. Then split the term. Plus 3k plus 63k gives me 66k plus my 21. That's it. I'm just splitting it up. Remember, when I'm done and I FOIL, that's what I get before I combine my like terms. So now we did that. Do you remember the next thing we did? I drew a line. just like that, and I GCF'd. So the 3k would come out. You'd be left with 3k plus 1. Do a quick check step, 3k, 3k, 9k squared, 3k, 1, 3k. Awesome. And then coming over to 63 and 21. 7, I'm hoping. 7. And then that would give me 9. Uh-oh, watch out. I'm going to show you what happens if you don't get the... I would get 9k. I like this mistake. Plus 3. Okay, now, I went along with this because I wanted you to see something. These don't match. I factored okay. 7 times 9 is 63. And then 7 times 1 is 21. But notice inside 9 and 3, there's a bigger, I didn't get the greatest common factor. I did not get the GCF. I got a CF. Because these have to match. So remember, I'm going to say I have 2 of them. I have a common factor and I only write them once. So I got to go back to the drawing board a little bit and think to myself, okay, there's still a common factor of 3 here. So that means that I should have taken that with the 7. 3 times 7 is 21. I should have taken a 21 out. Who could have seen that coming? That's a big GCF. All right, just goes to show you that factoring is really important. 21 is going to come out. That's going to actually leave me with a 3k, because 21 times 3k is 63k. And then, what was that number? I can't read it anymore. I erased it. Plus 1. Match. Matchmaker, matchmaker, make me a match. Do you know that Broadway show? Find me a find, catch me a catch. All right, now, I'll tell you in a minute. Hold, and you'll find out what Broadway show I am singing from. I copied the 3k plus 1 down, and now is the fun part of taking those outsides. What sign is the 21? Plus. And just writing them down. 3k plus 21. If I were a rich man, la na 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 na. Do you know it yet? All day long. That's the answer. If I were a wealthy man. All right. So we have 2 more problems. And I am going to start. Oh, by the way. Fiddler on the Roof, people. Classic. I saw it on Broadway. It was amazing. Okay. I want you to try these 2 on your own, because I think it's really important. I know that the trick probably out there seems pretty straightforward. I'm thinking you're feeling confident. Got to tell you, confidence is key, but until you try these on your own, you just never know if you have it or not. So go ahead and pause me, try it on your own, and then I'm just going to have the process out. You can check over the process. Again, all of this is coming from CUDA, so you know where to go for answers direct and more practice. This is, where did I get it from? This is factoring quadratics, and it's hard, not easy. The hard makes those coefficients on your quadratic term. So go ahead and pause me, and then come on back. All right, so we have, starting with 15, I have to do this. 15 times 6, because I don't know what that is. Break that into a 3 and a 5 and a 6. I like to see if I can do it that way. 18 and 5. Now 30 and 3. Oh, 30 and 3. There it is. Sorry, I should pause when I'm doing all that thinking. 30 and 3, and the 27 has to be negative. So that's going to be, because the 15 times 6 had to be negative. 15 times a negative 6 would be 15 times negative 6. I need a negative product. So I'm going to say, I'm going to move down, if you don't mind, move into this space. I'm going to say 15n squared minus 30n plus 3n minus 6. Split that down, and GCF. I'm going to take out a 15 this time. I see you. I see you, big factor, in minus, that's going to be 2. And then I'm going to take out a 3 here. It's positive 3. And that's going to be in minus 2. There's my match. I'm going to erase this because I need more room. And then I'm going to show you that the answer is n minus 2 times 15n plus 3. That's the answer to that one. Double check me. Let me know. Comment below if I screwed that up. And we'll move on to the last problem, which you either did or you didn't, and you're waiting to do it now. Here we go. Oh, 5 times 9. I actually know that that's 45, so I'll write it. But you're going to see, I'm just going to break it up to 5 times 9 again. 5 times 9 isn't going to give me 18, so I'm going to break this into 3 and 3, and there's my 18. 5 and 3 is 15, and 15 and 3 is 18. So it's 15 and 3 that I'm going to split it into. Here we go. We have a 5x squared minus 15x minus 3x plus 9. Oh, hang on. Splitting it down. GCF right here. We have a 5x times x minus 3. And then over here, I think I'm going to try and take out a negative 3. That way, my x can stay positive, so I have a match. And then, see those signs. Remember, this has to match. So if you GCF'd a positive 3, you actually have a negative x and a positive 3. That doesn't match. You need to actually take out a negative. Remember, you're trying to match. So if it doesn't match, you're going to have to manipulate it a little bit. Pay attention. Notice that it didn't match, and then just take out whatever you, need. Another option would be, if that confused you a little bit, since you know you need a match, write it there. And ask yourself, what would I have needed to take out so that this times this gives me this? And it would have had to be a negative 3, because negative 3 times x is negative 3x. Just a couple hints. You'll develop your own ways as you get more involved in algebra. That was supposed to be an x. There's my match. X minus 3. X minus 3. And here are the guys that go in the next one. So we have a 5x minus 3. Final answer. Guys, I hope this helps you out a little bit. I hope you enjoyed my singing of several songs from Fiddler on the Roof. And you know what? I just want you to go to CUDA, do some more practice on these. Practice makes perfect. And just keep in mind, I'll see you on the flip side.